So hello everybody. I'm Gergely Révay. I'm a penetration tester. I'm original from Hungary, and I know the title is a little bit boring, but I hope the presentation will not be as boring as the title. So let's begin. I will suggest a game first. This is a drinking game. If you have alcoholic beverages with you, then I dare you to drink all the time when I say request during the presentation. I will talk about web things, so it will happen quite a few times. If you don't have alcohol, just drink water and imagine how drunk would you be at the end. I can assure you, you would be hammered. So let's get on with it. This is the agenda of the presentation. So I will call the cross-origin resource sharing course because it's too long for me. I can't talk that much. First, I will talk a little bit what it is at all. Probably some of you already know it, but probably some of you don't. So I will explain what it is and how it works. And after that, I will go back a bit in time to talk about what kind of solutions were used instead of course when it didn't exist. Then, since we are talking about attacks, I will try to define a little bit the attacker. Then we go into the problem. What's the problem there? And at the end, I will show a few ideas how you can use this thing in web application attacks. Then, to be a little bit constructive, I will try to give some hints for solutions to avoid these kind of attacks. And I have some demos for the end that I want to show you. So what is course? As the picture suggests, it's an HTML5 feature. The whole idea of it is to be able to load resources from other domains. This is how roughly the architecture looks like. It's not that difficult. Actually, course is also not that difficult. Normally, when you have an application and you want to access another domain, it's limited by the same origin policy. That was the original thing. And course in HTML5 came to change this because there was a business requirement for that. So, for instance, if you run an application, you have your business logic, the application itself, in one domain, but you want to store your resources like pictures or videos or whatever in another domain, like in a storage or something like that, and you want to download these resources with JavaScript, so on the client side. Originally, it was not possible because of the same origin policy, because from JavaScript you couldn't go to other domains because the same origin policy stops that. And but since there was a requirement, the course came. The course was defined and implemented. But before course, when people figured out that they want to do something like this, of course, the clever developers started to implement some kind of alternatives, how they can manage this. Most of them were kind of hacks. They worked, but they were not really good. One example is to do proxying on the server side. So when you try to download the resource, then you will go to a proxy first, and the proxy actually will send you to the other domain. Or the JSON-P, it's JSON with padding. That's what the call snippet is here. This is JSON-P. Because since you couldn't send a request from JavaScript, so when I'm saying JavaScript, I'm talking about the XML HTTP request of JavaScript. So you couldn't send XML HTTP requests to other domains. But what people figured out that if you want to load JavaScript, you can load JavaScript from other domains. So if you use the source attribute of the script tag, then the browser will actually send the request to that URL, normally to download the JavaScript. But the people started to use it in a funny way. For instance, if you look here, you can see that this is like some kind of API here. We are talking about users, And this is some kind of user ID. And usually, in this case, usually there's a callback function defined. The callback function here is the parse response. And what it happens that when you load this script tag, there will be a request sent to this URL. And the server will take this data as actually the part of the parameters of the request. And it will process it, and you get back the response data wrapped around your defined callback function. And since this whole thing happened in a script tag, and the parse response function is defined on the client side, so it exists in your JavaScript code, then the browser will execute it immediately when you got back the response. I think you feel it as well that it's not really a nice implementation, but it worked. But everybody figured that it's not so nice, so that's why CORS was specified and then implemented in browsers with the HTML5 feature set. So how CORS really works? We define two kind of requests here. The naming is pretty stupid because there are not really good names for that. But we will define simple request and not so simple request. And the browser will have to make a decision whether the request, again, this is an XML HTTP request, whether the request is a simple request or not. But how does it make the decision? The trick is there that a simple request is very strictly defined. A simple request can be only a head, a get, or a post with these four headers and with these content types. Anything else is not a simple request. That's the definition. So first, when you define an XML HTTP request object, you create your request, and when you execute send, then the browser will look at your request and check out these things. And if your request complies with these rules, so it's, for instance, a get with these headers and with these, then content type, it's something interesting. So with these headers, then the browser will say, oh, cool, this is just a simple request. Then I can send it immediately. That's how it happens for a simple request. But if it turns out that your request was not simple, for example, it was a put, or it had a funny HTTP header, or a funny content type, then the browser will see it and then, okay, sorry, this is not a simple request, so what should we do? And what it does, you can see here, is to send a Preflight request. In the next slide, I will show an example of what a Preflight request is, but just to get the idea, you execute send, the browser here sees that this is not a simple request, then he sends a Preflight request, which is actually asking the server whether this kind of request is allowed or not. And the server will respond with a Preflight response, telling the client, the browser, whether this kind of request is allowed or not. And when the browser says, okay, cool, the server allows this request, then I can just send it. And then everything happens as normally. So your original request will be sent. But if your request is not allowed by the server, then the browser will just drop your request. It will not happen. It will not be sent. This is a Preflight request. It's always an options request. And what's important for us in CORS is access control headers. For instance, in the origin header. When you send an XML HTTP request, there will be an origin header telling the server where is this request coming from. It will be really important for us. And since this request was not a simple request, we can see here from this Preflight request that it was a put request because it asked the server whether put requests are allowed or not. And there it had this funny header, this XCustom header. And the server will receive this request, and if CORS is configured properly, then he will send back the Preflight response, simply telling the browsers that this origin is allowed, these kind of methods are allowed, and this header is allowed. And if the browser sees that that everything is allowed what the JavaScript asked for, then he will send the request. So for instance, that the original request here is allowed because put is allowed and the header is allowed, so it can go on. Yeah, that's pretty much coarse. Sorry?
I just wonder, why would anyone use a non-simple request?
Again, sorry, I didn't hear.
I just wonder, why would anyone send a non-simple request?
Because your service works that way. If you work with the REST API, you probably want to send put requests or delete requests because REST uses it. So if you want to, it depends on the service. It's not always that it's your service. It might be another service what you just use. So it's not up to you whether what kind of methods. But to be honest, a simple request is pretty strict, I think. So they are really simple. So as soon as you want to do something complicated, you will somehow start to use not simple requests. So the attacker, I will call him Neo, just for no reason. This is a basic like client-side attack architecture. So the attacker comes, he compromises a server somewhere, like a watering hole or something, and tricks the user or waits for the user to go there, download his malicious code, and then if the user is in an internal network, then the code will be executed here. So the attacker can either try to attack internal targets or external targets. So what kind of attackers we are dealing here? I will actually just ask questions here just to know that there are different kind of attackers with different goals. So what kind of knowledge the attacker has? I am a bit confusing here because when I say internal and external here, I mean that it's whether the attacker knows the system what he's attacking or not. So when I say internal, it means that the attacker has a dedicated target to attack. So you can imagine that it's an ex-employee and he knows that there is some application running in the internal network and he wants to attack that application, but he doesn't have access to the network anymore because he's an ex-employee. Or he can be an external attacker, an attacker without knowledge, and then he might use cores just to infiltrate the network, to look around, to see what kind of services are there, things like that. That's why I said that I was confusing, because now I'm talking about the location, whether the attacker sits inside the network or not. So he's either a local attacker in the same network where the target is, or a remote attacker coming from outside and try to get access somehow. And again, the goals, you can imagine plenty of different goals what an attacker wants to do. One could be, I've already said these things, to just get somehow access to the whole network, not to attack something just to get access, to attack the services in the internal network, or just simply steal data through this user. But how he does it? Yeah, so here you can see why I didn't go into the photoshopping industry, because I'm not really good at it. But what I wanted to show here is that the essential problem with CORS is that it breaks the same origin policy a little bit. Not really, so it's not like, so CORS is not a broken feature. It's not like it's not vulnerable, it's not totally broken. It's a well-defined feature, and it works how it works. But if it's not configured well, then you can use it to attack. And the problem is that people were trusting the same origin policy. And this was something which I wasn't expecting to happen, that you can just go around a little bit. So that's a problem. That's what we are going to use. And again, CORS is just a tool. It's not insecure. It's just a tool in the inventory of the attacker. So he can use this tool to make more complex attacks. And yeah, let's see the attacks. I assume some of you know the cross-site request forgery as like a set of attacks. But I will just explain a little bit about that because that's where CORS is really relevant. So I would call it CSRF because that's, again, a long stuff. So CSRF is a kind of vulnerability when you exploit the fact that whenever you send a request to a domain in the browser will attach the cookies to that request automatically. That's how the session cookies or the HTTP authorization headers, these will be attached automatically. And if you imagine that you are the user and you are logged in here in Facebook, you have actual session cookies right now for Facebook. And if Facebook would be vulnerable to CSRF, I think it is not, but let's assume. If Facebook would be vulnerable, then the attacker could just implement here on the malicious server a form, like a hidden form, to update your status, or so post on your wall or something. And when the user comes here and loads this page and submits somehow this hidden form, then the browser will send this request to Facebook because the form says it should go to Facebook. And since the browser already has cookies to facebook.com, that the cookies will be attached to this request. And that means that it goes in to Facebook, and the Facebook will never know where it came from, or it never checked. And your status will be updated. That's the whole idea of the CSRF kind of attacks. It's pretty well known, so there are plenty of different protections for that, which some of them we can circumvent with CORS. So that's about CSRF. And let's see the attack scenarios. The reason I explain CSRF is because we start with two different CSRF attacks. The multi-stage CSRF is a kind of attack where the process what you're trying to attack is multi-stage. Imagine a web shop. When you go to a web shop, you first choose the product and put it in your shopping basket. Then you go to the checkout. Then you set the delivery address. And at the end, you just click on, you make the payment and go home. So it's 4 steps. And if you want to implement this as an attack in like different forms and not using JavaScript, then it's pretty difficult because you have to get the user to do different things, and you have to send these requests in the right order. So it's pretty complicated. But since CORS, you can use JavaScript. That's the whole idea, that you can, when you have JavaScript, you can implement whatever you want. You can send requests in the whatever way you want to send them. So it makes like a multi-stage attack much more easier because you can implement it in JavaScript. The file upload CSRF, I will just skip it now because on the next slide I have an example. Cross-domain data theft. One of the demo will be about that. Is essentially there is a domain, you are the attacker, you don't have access to that domain, but you know a user who has. So somehow you want to go to the user and from there request the data from the target domain and steal it or smuggle it out to you. That's the cross-domain data theft. Complex JavaScript attack scenarios. As I explained in the multi-stage CSRF, with JavaScript you can essentially have a really strong tool to do stuff on the client side. And for instance, probably you know the browser exploitation framework, the Beef. It runs in JavaScript, and for instance, with Beef also exploits CORS. So for instance, when you have with Beef, you have a compromised target, so compromised user into the internal network. Then with Beef, you look around and see a service you can attack, like a web server or a SMTP server or something like that. Then you can exploit that with Beef. You can open a backdoor there, and then Beef will do the communication with the web door, so you're communicating from the browser to the exploited service, and this communication will be done using CORS. That's how, for instance, Beef uses CORS. And network enumeration. There are tools on the internet what you can use to kind of nmap the internal network from JavaScript. It's they are not so sophisticated because they usually use measures based on delays So the response delays to decide whether a port is open, whether an IP exists or something like that. So they're not really sophisticated, but it's possible. And yeah, the example. So the file upload CSRF. Actually, I was doing a test. It was a pretty simple application. There was a login and a file upload form. That was the application. So obviously, I wanted to do some kind of malicious file upload because that's the only thing what I could do. So what I tried to do is, so when you use the normal file upload form of HTML, it will generate you a multi-part request to upload your file. As like this is the file part of this multi-part request. And it turned out for me that you can't fake this request with a normal HTML form. So normally you can fake requests with HTML forms. So the normal forms, but you can't do the same request as the file upload HTML form because of this innocent parameter here, this file name parameter. You can't really put this in a normal form because you just don't have the tools in HTML to do that, or at least I couldn't. So yeah, if you know a solution, let me know. But and that was the time when I found out that CORS existed, because with CORS it gets much easier. This is an HTML page, and this is to exploit this file upload CSRF. This means that when the user visits this page, he will see a submit button. Actually, it's not necessary to have a submit button, but it was a proof of concept. He will see a submit button, and when he clicks on the submit button, this JavaScript code will upload a file to the server. And since it's JavaScript, you can do whatever you want. So you can put here this file name thingy, what was not possible with the normal form. Actually, it was funny because when I find this, first I implemented it by myself, and it turned out that the next day, Portswigger released a new version of the Burp suite, and they implemented just the same thing that you can generate these proof of concept code. So this one is actually generated with Burp. Just I changed it a little bit. Yeah, so here essentially CORS allows you to upload files in a CSRF vulnerable web service or web application. That was the main point. And as I mentioned already, CORS is not broken, so it has pretty strong limitations. You can't always use it in a way that you want, because actually it was designed more or less with security in mind. So there are like stuff about that in the specification, but so you have to know these limitations. One, which I called the write-only request. What happens here is that the browser has the right to decide whether it shows you the response or not. So you send an XML HTTP request. It goes to the server executes the actions what you wanted, sends back the response, and the browser gets the response, and he can make this decision whether you can see this response or not. When I say see, it means that from JavaScript, if the browser doesn't allow it, from JavaScript you can't read the response object properly. You won't see the contents. Even in Firebug, for instance, you won't see the contents of the response. And the whole idea was here is that to give the server the ability to do like, he can say that, yeah, I do what you asked for, but actually, if you don't comply with these things, then you shouldn't see the response. It's a bit weird for me why this idea came, but that's how it works. And these are the cases when this happens. So for instance, the response should always have an access control allow origins header to tell the browser that your origin is allowed, so your domain is allowed. If this header it is not in the response, then the browser will not show the response. When this header is not in the response, that essentially means that course is not turned off on the server side. So, yeah. The second case is if there is this access control allow origins header, but the origin where you are is not defined there. That means essentially that the server says that, okay, I give you the response, but this response is only for this and this and this origin. And if you're not in that, then the browser will not show you the response. And there is a tricky one, which was also surprising for me. Here, this ACAO is the access control allow origin again. And you can define it with the allow all, so this star. And with that, you're saying that I enable course, and I allow it for everybody. So you can come from any origins, you can have my stuff. And the funny thing is that now in JavaScript, in XML HTTP request, you can say that, you can tell the browser that, please attach my cookies, attach the proper cookies to this request. This is the with credentials property of the XML HTTP request object. So you can say with credentials equals true, and then the browser will see, okay, then I have cookies here, I will just attach them. But if the response comes with this allow all access control allow origins, then the browser will not show you the response again. It's just, I think it's just a measure to say that if the server is not configured properly because it allows everything, then at least we shouldn't do stuff with credentials. I think that's the essential point of it. And actually, it's from defense point of view, it makes sense. So I had attacks where this was my problem, that I couldn't do my attack. And one last thing, the requests are sent. So the requests always go to the server, it will be executed there, and it comes back even if you can't see the response at the end. The thing what you asked for will happen at the server side, but you just can't read the response. Another limitation is what I already explained, when the Preflight request fails. That means that you defined a not simple request, the browser sends an options request, a Preflight request, the server responds, and it turns out that you're not allowed to do that what you wanted. Then the browser will just drop your request, and that's it. So until now, what I said. So we're talking about cores, and it's to access other domains from JavaScript. We defined the attacker model. I showed some scenarios, some attack scenarios, and to be a bit constructive, I will just give some ideas for solutions. The first one is to let people understand cores, and that's what I'm trying to do right now to explain, because if you're developers or admins or things like that, you will probably want to know about this stuff, because it might affect your service or your application. Then, yeah, as always, you should be as strict as you can, strict with the origins. Think about whether you at all want to support something like that. If it doesn't make sense for your application, just don't use it, turn it off, reject it. You also shouldn't allow credentials if you don't want. So if there's no business call for that, then don't allow people coming to you from JavaScript with credentials or session cookies. And there is a little bit of change of mindset here, because now it's also the developer's problem. And it's because of this. If you want to do hardening, you can do now it in various levels, on the web server or container or whatever where your application runs. Or you can do it in the application itself, so in the application code. For the web server level, a really simple example is the Apache HTTPD. You can just simply use the mode headers module defined either in the config or in the htaccess files, and set the header, set the access control URL origin header as strictly as you can. There's a website called enablecourse.org or something like that, and there are a few examples how you can turn it on. And actually, it's a nice website because it explains a lot. But I think it's a bit stupid that enabling course is the suggestion is to set it to allow all, so to the star. And yeah, I think it's a bit stupid that that's the basic suggestion. But yeah, it's not my website. And the other level, the application level, I'm not a developer, so probably there are other very sophisticated ways. But the point is, you can set the headers from the application code as well, depending on the business logic of your application. So whenever you want to allow the course to function, you can set it, you can allow it, and the other part of the business logic or your application, you can just reject such things. But the interesting part here is now developers also need to think about these things. Yeah. And I don't say thank you yet, because I still have 12 minutes, and I have demos as well. I have to be honest with you. I'm not that brave to do live demos. So I recorded the demos in videos, and I will just explain them right now. Yeah, so the first one is with the Sugar CRM. It's a half open source, half commercial CRM application. But you can go to the internet and you can test it just on their website. And yeah, and that was an application which I tried to find something to use course, and it was pretty interesting. So let's see what's happening here. So in Chrome, in this browser, we are logged in as Jane, and Jane is a regular user. I don't know whether you can read it or not. And in Firefox, we're logged in as the admin and looking at Jane's profile, still regular user. What our goal is to escalate Jane to system admin user. And here, you can, at the bottom, you can see that there is a cookie, a session cookie. And the funny part was, I didn't understand it first, that this cookie expires in 60 seconds. So it's only valid for 60 seconds. I don't know why they do that, but it's some kind of protection against CSRF, because if the website is just open in your browser and you're doing a CSRF attack, then you have just 60 seconds to do that. Otherwise, the cookie will expire, and the browser will not attach it to your request when you're doing the CSRF. So you can see it here that this cookie is actually already expired. And yeah, let's see what we are going to do. I have a little JavaScript here. It's pretty long, but only because this is a request to change your profile. And you can change a lot of stuff, that's why it's so long. But the important part here is at the beginning, because what happens, I really don't understand why, but since your cookie expires in every 60 seconds, when you do something on a website, you get another cookie. You don't have to authenticate again. You just get the same cookie back, again for 60 seconds. It's totally weird, but it helps a lot in this attack. So that's why it's actually vulnerable, because yeah, it's the same cookie. So it's not even a new cookie, but for this attack, it doesn't matter, but it's the same cookie.
So it's just like a timer when the user is not active for 60 seconds?
Yeah, something like that. But yeah, as you will see, it's not working good. So what I'm going to do here, this first part of the script is actually just sends a GET request to the service without credentials, without anything. Just sends a GET request, and just the reason is to get back a cookie. So to make sure that there is a valid cookie. So after this GET request, you will have 60 seconds to do your attack. because there will be a cookie there for 60 seconds. And as I talked about the write-only request, it's really good because in this case, it doesn't matter whether you can read the response or not, because the browser will automatically set the new cookie. You don't have to do anything with the response. You just send the get, and the browser will do the rest. And after this, I will send my malicious request. It's a simple post request to change this. I think you don't see it pretty well. It's the isAdmin attribute of the profile request, and I set isAdmin to 1. That's the trick. Now I just do stuff, and let's see how that happens. So I have this website. You can see here that it runs localhost. The important here, it's not that it's localhost, it's that it's in another domain. So it's not in the target domain. It's in another domain. And I have to trick the user, of course, the admin in this case, to come here and open my URL. When he opens it, in this case, click on the button, but it's not necessary. When he clicks on the button, you can see at the bottom that first our GET request is sent to get the cookie, and a few seconds later, the POST request is sent to set us to admin privileges. And the cookie is in the response, that's in burp. So if you look at the GET, in the request, there are no credentials at all, no cookies, nothing. It's just a simple GET request, but you still get back the cookie for 60 seconds. And because of that, the POST request is, I was pretty confused when I recorded this stuff. The POST request will have a valid cookie, as you can see there. And you can see that it has the isAdmin set to 1. The response is not too interesting, it's just a redirect, but at least something happened, so it's not an error message or something like that. But if we go back to the browser, first this is the session of the admin user. I will just go to edit mode just to reload the page, essentially. And ta-da, you can say that Jane is now system administrator. But the better part is if we go to the other browser, to Jane's session, and we reload the page, Jane can already see that she's a system administrator now. So what happened here, the important part was here that we could use course to do the request from JavaScript and to circumvent this funny protection of the cookie timeout. That was our goal, and this allowed us to do privilege escalation for Jane in the admin's session. So that was one example, and I have another one. I've chosen a wiki because I think every company has a wiki, an internal wiki, where people have pretty confidential information on the page. Usually these wikis are not require authentication to read the stuff what is on. You only need to log in if you want to change something. But in this case, I don't want to change anything. My only goal is to steal the secret, super secret plan from the internal wiki. I'm an external attacker. I don't have access to the internal systems, but I know that there is a super secret plan on the internal wiki, and my goal is to smuggle it out. And that's what we are going to do here. You can see this is our domain, this IP address, and this is the super secret plan URL. As the attacker, I already know that because that's how I build my exploit. So probably I'm like an ex-employee or something. And yeah, I just want to smuggle the stuff out because they fired me, bastards. And here is a JavaScript. Thank you. Here is the JavaScript code. It has two parts. The first part is to actually download the super secret plan to the client, to the browser. As you can see there, I call this request request URL function with the URL of the super secret plan. And that means that I download the stuff to the browser. And then the second part of the attack is to send back this wiki site to my homepage, to my domain. So that's how I'm smuggling it out from the internal network, because my domain runs on the internet. Yeah, no attacker should use this script because it's like vulnerable for everything, probably. But what it does when a post request comes in, it will just write the content of the post request in a file, just that we can see, we can load it in a browser. That runs in the attacker's domain, this script. Yeah. So there is a website. Again, it's on the internet. Here it's localhost, but let's imagine that it's on the internet. And you can see it's a totally innocent website. It's for My Little Pony fans, because we know that the target user is a My Little Pony fan. So he or she comes here, and yeah, just for the introduction, you had to scroll over the picture, and something happened. What happened here is you can see that first there was a request, a GET request to download the plan, and then a POST request to send it to the attacker's page. If you look at it in Burp, we can see here there is the GET request. Again, no problem with it because it's a simple request and it has no credentials at all. And in the response, one important thing is that course is enabled. So it's enabled for all. So that's a problem here. You could avoid this stuff by configuring it well. And now you have the whole wiki website in the response, or like this web page. And now we go and send a post request to the attacker's domain, and in the content, it's the same HTML code from the wiki in URL encoding. Yeah, response is not really interesting. It was accepted. Now let's see whether it worked. If you go there, you can just load. If you remember, the incoming HTML was the file where I wrote the wiki page. So we can load the incoming HTML. And ta-da, it's there. So the fact is that I could smuggle out an internal wiki site and put it on my website or my server on the internet. So that was our goal. And this was possible because course was not configured properly, because I could just send XML HTTP requests to other domains. Yeah, that's that. And that was more or less it. So do you have any questions? I can tell you in version numbers, but Firefox, Chrome, and Internet Explorer has. Just in Internet Explorer, the XML HTTP request is defined in another way, so the object is called in another way. But they all have since HTML5. So it's a totally normal HTML5 feature. So all browsers who support HTML5 will support this one. Yep. Sorry? Uh-huh. Oh, yeah, OK. Mm-hmm. Yeah, OK. So he was saying that Internet Explorer supports it partially. So yeah, I didn't really use Internet Explorer, so that's why I didn't really go into the topic. Yeah. Any other questions? No, then thank you very much that you were here. And yeah, have fun for the weekend.
Ladies and gents, Gergely Révay.